Okay, hi class.
Hello.
So let's come back together. Math time. 3, 2, 1. Okay, so I want you all to look at your task. I'm going to read it out loud so that we're all on the same page about what we're doing today. This is called, we're doing a hexagon challenge. So I'm going to read this for you. For the pattern below, compute the perimeter of the first 3 trains, determine the perimeter for the 10th train without constructing it, and then write a description that could be used to compute the perimeter of any train in the pattern. So I want you to think just for a moment in your head about what you're asked to do. Okay, think for just a moment. So I've drawn the first 3 trains on the board here, and we're going to talk a little bit before I let you go to get started. We're just going to kind of make sure that we're all on the same page about what we're doing here. So first let's start with the shape. We've been doing shapes, but we haven't come back to them in a while. So can somebody tell me what shape is this? Erin, I see your hand. What shape is that?
A hexagon.
How do you know that it's a hexagon?
It has 6 sides.
Okay, so you're saying that you think it's a hexagon because it has 6 sides. Now, does every hexagon have 6 sides?
Yes.
Okay, well what about this train? How do you know that, is this the same shape here?
They're 2 hexagons stuck together.
Okay, yeah, and then this third one has a third hexagon. So they call them trains, so it's almost like these are train cars. And does everybody see that we have a pattern happening here? The 4th train that's on your paper has 4 hexagons. How many hexagons do we think is going to be in the 6th train?
6 hexagons.
You think there will be 6 in the 6th train because it's following a pattern, right? It's increasing by a hexagon every time.
Yes.
Yeah, that's right. So can somebody remind me? It says to find out what the perimeter of the 10th train is without constructing it. So somebody remind me, what does perimeter mean? When I'm trying to find the perimeter of a shape, what am I trying to find?
Like the outside?
The outside. So if I, for instance, was trying to find the perimeter of this rectangle, would I be looking for the amount of space on the inside, or how much how long the outsides were all added up together?
How long the outsides?
Yeah. So it's how far it is around the outside. Yeah. So I want you all to, on your paper, for train 2, I want you to trace the part that would be the perimeter. So do that for just a second. Just trace over with your pencil which lines would be the perimeter, and think in your mind what line would not be in the perimeter. Okay? Okay, so I'm going to do that too. So check and see if what you traced is the same as what I'm tracing. Did everybody trace the same thing that I did?
Yes.
Yeah, so the perimeter here is just the outside. That means we're not going to count this piece here in the middle. So we're also not going to count these guys. So can somebody tell me if, for instance, this is 2 hexagons sort of stuck together into a train. What if I had 2 hexagons that were not stuck together? What is the difference? So if I was going to subtract these, what would be the difference in how many sides there are here versus how many sides there are here? How many is it changing by? Erin, what do you think?
The 2 middle ones.
These 2 middle pieces.
Mm-hmm.
Yeah, here, those 2 middle ones are kind of kissing, right? They're kind of smushed together and they don't count anymore. So when here, I'm going to eliminate 2. How many do I eliminate in the 3rd train? Does everybody know what that word eliminate means? In this case, it just means it's not counting anymore. We're not counting it anymore. But you might think of it as getting rid of, like we're almost erasing it. So how many of those sides of the hexagons are we getting rid of?
4.
We're getting rid of 4. Interesting. So here we got rid of 2, like a -2, right? Here we got rid of 4, like a -4. So I want you to think in your mind, how many did we get rid of in the 4th train? Can somebody look and see how many on your paper? How many do we get rid of in the 4th train? Think about that in your mind. Can I get somebody, Erin? How about you? You haven't spoken today. How many do we get rid of in the 4th train?
6.
Oh, we got rid of 6 of them. Does everybody see why I'm using a minus sign? Why would I be using a minus sign, Erin?
You're taking away the sides.
Yeah, so instead of counting all of the outsides, it's like I'm counting those outsides and then taking out the two that are going to be touching, okay? So we've been studying in our class ways to arrange data, and we haven't really applied this to patterns before, and so I'm going to show you that when you do patterns like this, oh, and by the way, how many get eliminated out of that first train? Did any get eliminated out of that first train?
0.
No, so that's a 0. So you could think of it as a -0 because we're not taking any away. So we've been applying things like charts and graphs to our stuff. So I want us to think about this in a table. So if I was to think about this in a table, oops, there's something between there. What might we put in this side of the table? What might we put in that side of the table? And then how could we use this table to help us figure out what's happening with the numbers? And is there a way to generalize to what's going to happen at number 10, even if we don't have to draw it? So that's where I'm going to leave you to work in your groups. And I want you to be thinking about how can I take the information in this table and turn it into sort of a set of instructions or a description that matches every train, not just these 4, not just train number 10, but every train. All right, so we're going to work in our groups and then we'll come back together at the end.